Okay, so the question that we're going to be answering today is a projectile is shot upward from the surface of the Earth with an initial velocity of 84 meters per second. First, we have to find the position of this projectile, so I'm actually going to do that before I even read off the next questions. And we're going to start with this equation here. And what this equation is it represents the position of the function of the projectile when we start. So, looking at this, G is going to be a constant depending on whether we are working with meters or feet. G will either equal negative 9.8 meters per second squared, or will equal negative 32 feet per second squared. V subscript O is our initial velocity, which in this case is going to be 84. And then S subscript O is where the ball or whatever you are throwing started from. As right now, considering we were not given a specific location as to where it started, S of O is just going to equal 0. So we are using, in this equation, meters, so we're just going to plug everything in to find out this first answer, which is the function of this projectile. So S of t is equal to half of g, which is negative 9.8 times t squared, plus v of t, which is 84 times t, plus 0. So our S of t is equal to negative 4.9 t squared plus 84t. And this is the answer to question A. So the next question is, find the average velocity of the projectile from 3 to 5 seconds. So velocity is equal to the derivative of S of t. So I'm just going to write that real quickly. So to find the average, we're going to take the derivative of S of t1, where t2 is equal to 5, and t1 is equal to 3. So we're going to take the derivative of t5, subtract the derivative of t3, and then we're going to divide it by 5 minus 3. So that equation will look like this. T2 minus S of T1 all over 5 minus 3. So we're just going to plug that in really quick. So our derivative is going to be, if we bring down the 2, multiply it by the negative 4.9, it's going to equal negative 9.8 t plus the derivative of 84t, so we bring down the 1, t goes away, so it's going to be plus 84. So negative 9.8 times 5 plus 84, this entire thing, minus negative 9.8 times 3 plus 84, all over 5 minus 3, which is 2. So when you do all the math, you're going to end up with derivative of S of t is equal to 35 plus 54.6 over 2, which is equal to 89.6 divided by 2, which is equal to 44.8 meters per second squared. So this is going to be your average velocity. So for part C, we are just going to find the velocity of the projectile at 3 seconds, which we kind of did here. I didn't work out all the steps, so we'll go through and we'll do that now. So that is basically the same. It's the derivative of S of 3 So that is going to be equal to negative 9.8 times 3 plus 84, which is going to equal 54.6 meters per second squared. And then the final part simply asks us to find the acceleration of the projectile at 5 seconds. Now, to find the acceleration, that's basically the derivative of the velocity. So we can say that a of t is equal to v prime of t. So basically we're just going to take the derivative of our derivative. So our derivative is negative 9.8t plus 84, and this is v of t. And we're going to find the derivative, so v prime of t is equal to negative 9.8, bring down the 1, get rid of the t, so negative 9.8 times 1, plus the derivative of a constant, which is always going to be 0, so plus 0. So our acceleration at 5 seconds, excuse me, put down the wrong number, is going to equal just simply negative 9.8, because we no longer have a t to plug in the 5. So that's it. This is going to be per meters per second squared. And there you go.